One of my favorite studies has got to be advancing human hibernation capabilities.
So we funded in-human study where we looked at reducing metabolism using a pharmaceutical. They were groggy and were conscious but groggy and mostly slept, and then were awakened for a period of 4 hours a day where they could exercise, they could eat.
We're going beyond simply looking at what actually causes the metabolic manipulation and how to do it in humans. We're looking at what the actual costs of doing it are.
So if we can discover a new way to reduce the metabolic load of the human body in space, we can send up less food. We can produce less waste. We'll sleep longer, perhaps, during these space missions, and thus reducing our boredom and our stress levels. Maybe we can put them in some sort of radiation-proof pod while they're sleeping.
When you lower metabolism of an organism and you generate less metabolic waste and you don't rev up the engine of the body, if you will, quite as hard, then you have longevity producing effects. And what I mean by that is even the effects of space radiation might be mitigated partly by reducing metabolic rate. So I think it has a lot of implications for the health of future astronauts.
What we actually get on the other side in terms of reduction of metabolic rate, which might actually help us reduce the needed overall supplies when we go to Mars.
I think it's one of my favorites because it's really forward-thinking. It's really sci-fi. It's something we've always dreamed about, clearly, in our pop culture. And I'm really proud to be part of TRISH, where we advance the real science behind those sci-fi kind of ideas to move forward towards what's possible.